Here's a quick video to get you started on polynomial functions. It's absolutely crucial that you actually graph these, and it doesn't mean that you have to graph them with complete detail. You want to get a quick sketch of every one of these functions. We want to see what happens with linear, quadratic, cubic, and quartic functions. And notice and recognize patterns, because when you notice and recognize patterns, that helps you remember the things that you're learning as opposed to just being told what happens when you have various polynomials. So please, please, please go in, use Desmos, use your graphing calculator to graph these out. We can make some quick sketches, but there are certain things that it's faster to have the calculator perform. So for example, with our linear function, our first one is f of x equals 3/4 x plus 2. So we would know that we would go up to rise 3, run 4, and create a really quick sketch of this graph. So because this has a positive slope, it's going to be increasing or rising on the right-hand side of the graph. We're not sure what the zeros of this are, so we can go to our Desmos graphing calculator and plug in 3/4 x plus 2. And we get our line. When we click on the line, we can find out that our 0 is -2 2/3. And because it's a line, it doesn't do any turns, so it has 0 turns. Second example, we have y equals 4x minus 3, so we could do a quick sketch. We're 3 on the y-axis, rising 4, running 1. And once again, we have a line rising to the right. 4x minus 3. Has a graph that looks like this, so it crosses the y-axis at -3. And once again, 0 turns. So do yourself a favor, sketch these out, figure out what their graphs are going to look like, and some of them you know. F of x equals x squared. By now, we'd better be able to graph a parabola. Quickly, accurately. It's rising on the right or increasing on the right. It has a 0 at 0, and it has 1 turn. So please take the time to actually work these through. Pause the video now, finish them off, and then start to look at the questions. What do you notice about all the polynomials that rise on the right or that are increasing on the right? What about those that fall on the right? And so forth. Take the time, do the work, and then come back and see if you can come up with the same conclusions. So pause the video. All right, hopefully by now you have worked your way through all of this. And you will have a complete sketch of everything that was going on. So when we're looking for patterns, what happens with all of the ones that are rising on the right? Well, here's one that's rising on the right. Here's another, a third, a fourth. So we want to check and see, what do all of these equations have in common? Three fourths x plus 2, 4x minus 3, x squared, x plus 2 squared, x cubed, 2x cubed plus 5, hopefully you notice that all of them have a leading coefficient that's positive. When the leading coefficient is negative, it's falling on the right. What do all the polynomials that do the same thing on the left and right have in common? Well, none of these do the same in the left and right. Linear's out. But the quadratics are all doing the same thing on the left and right. They're either rising on the left and right or falling on the left and right. Cubics are out. Quadratics, quartics, my fault, look like they are all doing the same, have the same end behavior on both sides. What do they have in common? Well, guess what? They are both even. The highest power, or the degree, is even. And when they do the opposite, they have an odd degree. How are the number of zeros related to the highest power of the polynomial? Well, we had 1 0 here in each of these. This one had 1 0. This one had 2, 1 and 2. A cubic power of 3 has 1 0, 3 zeros, 1 0, another 0. So it looks like it can have more than just 1, up to potentially 3. And then the quartic has 1 or 2 or 2 or 4. So it appears that a quartic can have up to 4. Quartic means 4, up to 4. So it appears that the number of zeros are based on the highest power of x. X, or x's degree, or less, are the number of zeros. How many turns, or relative mins and maxes, does each graph have? Well, 0 turns on a linear, 1 turn on a quadratic, 2 turns on a cubic, and 1 or 3 turns on a quartic. So it looks like they're all at least 1 less than the highest degree. And then you want to make some predictions. So what do you think will happen with this 5th power, this quintic? What do you think the end behavior will be like? How many zeros? What's the maximum number of turns you'll get? Then graph them to see if you're right, and decide what's happening on the right, how many zeros there are, the number of turns.